Linear algebra. What is linear algebra? Linear algebra, mathematical discipline that deals with vectors and matrices and, more generally, with vector spaces and linear transformations. The concepts of linear algebra are crucial for understanding the theory behind machine learning, especially for deep learning. They give you better intuition for how algorithms really work under the hood, which enables you to make better decisions. Mathematical objects. There are four main mathematical objects in linear algebra. 1. Scalar. 2. Vector. 3. Matrix. 4. Tensor. Scalar. A scalar is simply a single number. For example 24. A scalar quantity is defined as the physical quantity with only magnitude and no direction. Some physical quantities can be described just by their numerical value without directions. The addition of these physical quantities follows the simple rules of algebra, and here, only their magnitudes are added. Examples of scalar quantities. 1. Mass. 2. Speed. 3. Distance. 4. Time. 5. Area. 6. Volume. 7. Density. 8. Temperature. Vector. A vector quantity is defined as the physical quantity that has both directions as well as magnitude. A vector is an ordered array of numbers, and can be in a row or a column. A vector has just a single index, which can point to a specific value within the vector. For example, v2 refers to the second value within the vector, which is -8 in the graphic above. Matrix. A matrix is an ordered 2D array of numbers, and it has two indices. The first one points to the row, and the second one to the column. For example, M23 refers to the value in the second row, and the third column, which is 8 in the yellow graphic above. A matrix can have multiple numbers of rows and columns. Note that a vector is also a matrix, but with only one row or one column. The matrix in the example in the yellow graphic is also a 2 by 3 dimensional matrix, rows x columns. Below you can see another example of a matrix along with its notation. Tensor. You can think of a tensor as an array of numbers, arranged on a regular grid, with a variable number of axes. A tensor has three indices, where the first one points to the row, the second to the column and the third one to the axis. For example, T232 points to the second row, the third column, and the second axis. This refers to the value 0 in the right tensor in the graphic below. Tensor is the most general term for all of these concepts above because a tensor is a multidimensional array, and it can be a vector and a matrix, depending on the number of indices it has. For example, a first-order tensor would be a vector, 1 index. A second-order tensor is a matrix, 2 indices, and third-order tensors, 3 indices, and higher are called higher-order tensors, 3 or more indices.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.